Okay, so let's keep cruising along here with the overview of masonry. So masonry construction, just some photos here of laying the masonry block, um, layout and leads and line. Basically, use just what it says. A line is string line, um, end, layout, leads, layout and leads so that you basically keep a straight line and you keep plumb um, when you're doing the walls. So these are kind of construction items. They will typically, if you've got anything that's above head height or above kind of 5 feet, you'll need scaffolding. This is a stationary scaffold, but it's not as simple as having some ladders because they have to continue to go along horizontally as they go up each row. It takes a little more labor, and the higher walls are going to cost more. Here's an adjustable scaffold where you can just continue to put up the scaffold level as you move up. There you go. Can't be afraid of heights if you're a bricklayer that does anything over about 5 feet. All right, so let's look at the masonry elements. Um, a lot of this is detail that it's helpful for you to know as a structural engineer. We've talked about some of the terminology, but I in particular want to show you kind of some wall layouts. There's some things in here that really the architects see a lot of, but as engineers, structural engineers, we don't see as much, and it's really helpful to know how this all goes together. All right, so as we talked about, we have the coarse and the white, right? Okay, so I'm sorry, the coarse, and then the vertical. This is a white, and this is a two white wall, okay? Whereas one of these would be a single white wall. You can have a solid wall, you can have a composite wall, you can have airspace in here, a cavity. You can have a CMU wall with veneer on the outside. You can have columns, beams, right? There's all kinds of different types of masonry elements. Single width wall, so that's just a single width is one way you can think of width. 1 brick wide or 1 CMU wide. If it's only single wide, it's a non-load bearing or load bearing, but you don't have a ton of stability with 1 width wide, depending on whether you're looking at how tall the wall is. This is the stack bond. Structurally, we don't typically use this. If you played with Legos as a kid, you can probably imagine that this is not a good idea. Single width walls. Here's a running bond. In other words, they've got continuous running through here. There's also, in this case, I think I can see some reinforcement. Okay. Stack bond, this is the one we don't use. You will see this around, but they're usually older structures or like the 60s. Foundation walls, very common use for CMU. You go into a house, get your house inspected, and there's typically going to be some nice cracks like this. What is that? That's basically a shear crack that's following the mortar joint. And more foundation walls. Here you can see that continuous, remember the tub-shaped section, and here's some reinforcement. So why is this here? It's because it's tying this together, and here's an opening. Likewise, I've got my reinforcement coming through. Here's a low-rise building. It's a combination of using walls that are CMU with steel frames in this bigger unit and lighter frames over here. That's just the studs, but these are metal studs. So, we learned a lot about wood studs. In commercial buildings, you have to use metal studs, which honestly are kind of a pain, but it has to do with fire rating. This is what we call a backup wall. You see the pieces sticking out here, so they're going to have a brick veneer or some kind of facing on this, and it's got to tie in to, so they'll lay these guys that are sticking out will go in between a brick layer to hold it in place. Here's some different types of walls. So you can see that you can have metal ties in here to pull these together. Here's another structure where I've got, and you'll see these sometimes, you see the little single, you think, oh, that's a cool pattern, but it's really to kind of bond the two pieces, the double width pieces together. In this case, you can see we've got a course of them sideways, these headers, and we've seen that in some of the pictures I've shown. So these kind of solid, double wide, all masonry brick type walls are not as common anymore, but you'll see them. A lot of what you'll do, in addition to kind of the low rise CMU block walls, is around here, particularly in Duluth, you're going to deal with a lot of historic structures. And so you are going to see this stuff if there's repairs or retrofits being done. Here's some walls that are some different variations. I can reinforce at the joints, right, in different ways to tie this all together. And you see that there's this brick piece, and this is tying the brick piece into the CMU piece. It's in two other versions, or I have a grouted cavity between the two sets of brick. Cavity wall. This is pretty common. Connected with metal ties. So we start looking at this wall type. You've got your CMU block here. This is the CMU block. Here's your brick. And then in between, we have it can be a lot of different things, but a combination thereof with some airspace, right? Airspace or some rigid foam and some airspace. And there's a place where the moisture can collect and get diverted to the exterior of the building. Typically, the inner one is the load-bearing white, and the outer one is non-load-bearing. So in this particular case, we've got a brick non-load-bearing facade, yeah, and then we have the CMU load-bearing inner wall. Okay. I won't go into all this, but one of the things that can happen, we're not in a seismic region, but just because I told the wall that this is the structural wall and I designed for this, once I tie it into the non-structural or non-load-bearing wall, that's fine for strength purposes, but just know that this is going to probably, depending on the tie back, is going to increase stiffness. Okay, so sometimes we end up with a non-structural piece that no one told it that it's non-structural. You know, if I'm trying to be silly about it, but it's going to collect load. So there's a lot of things we do in non-seismic regions that we have to just think twice about. They still do this type of connection, but you have to be very cognizant of how it's going to behave, because the higher stiffness items attract the force. They also dissipate the energy through cracking. Okay, so here is you could actually find this if you just type in kind of masonry walls and stuff on Google. You can find versions of this. It's kind of fun to look through and see what's behind all these walls, unless you've had a chance to do some work like this. This is a pretty typical looking one. So I've got my foundation, right? My concrete foundation. I've got my slab on grade. Here's a moisture barrier, insulation barrier over the ground. Here's my slope that we want to go away from the wall. If you've got a lot of drainage problem, and you may have a French drain of gravel in here to take it away too. You've seen this stuff probably sticking up from the foundation in buildings, because around here it frost heaves and ends up, you see it peeking out. But this is the insulation that's supposed to be below grade, and there's waterproofing there too. Here's my masonry unit wall. Here is the reinforcement. Here's the grout filling, and here's the mortar joints. Okay. And then in here, they've got my flashing system to divert water. I've got my exterior brick wall. I've got a rigid insulation. So you see that stuff in sheets at Home Depot and Menards as well. You've got a vapor barrier behind here. And then you have actually an airspace in here. Okay, so they recommend a 2-inch airspace. or 1 inch minimum required for drainage wells. So I've got air, and you see these are tied in through here, this whole thing. So the air, you'd think, oh gosh, air is actually a good insulator. So it's, it's not as good as whatever an high R value insulation, but air is actually a pretty good insulator. So you've got a space to deal with drainage and moisture issues, and it's not a problem for insulating. So you've got this deep thickness where you've got your wall, your barriers, your foam, some airspace, and then the brick veneer. But the brick veneer is importantly not standing out here by itself. It's tied back in to the wall. Okay. Here's some other examples of veneer walls. Sometimes you might have a metal stud, sometimes, and some sheathing. In this class right now, we're talking about, so we talked about some of that with wood. This is a metal one. Our CMU units, we've got some kind of tie coming out here and a little cavity between the two. Okay. Reinforcing steel. So this is the more structural part of this, right? If I don't have the reinforcing steel, I only get to count the compression. Okay. Like concrete, I only count on the masonry units in compression. So if I would like to actually have some tension in this thing, I do need the reinforcement. It also serves to tie this together. This is a spacer for the reinforcement. You can't just stick the bars, contrary to what you sometimes see in the field. You don't want to just stick the bars in there and hope everything works out. We'd kind of, we're going to have a distance to the bar D, same stuff we had in concrete design. So we'd like it to be pretty close to where it's supposed to be. Number 9s are about this big a bar as you're going to see in this application. So number 3s to number 9s. So these are basically the bars that we typically use for stirrups and beams, but not the oversized bars. ASTM grade for the reinforcement, typically grade 60 KSI, which we're used to. Okay, so they're basically the same stuff as cast in place. They help us with strength. They can also help us with deflection. So we also can reinforce the joints. So basically I've got my wall here, and this is between one of the layers where I have a ladder or a truss, and then this is just sticking out if I need to have ties back into the brick. So we've seen a bunch of examples of that. Controls shrinkage and in-plane shear. If I tie multiple withes together, so these are typically a 9-gauge wire, so about 3/16 diameter. Here's some great pictures of a little bit of everything going on. So this is helping me with my spacing. It's also tying everything together, right? And see, you just lay it in between. The brilliance of here is I'm not having to drill anchors in or anything like that. I just lay it between the layers. So I've got one going this direction, and then I've got the ones tying in, and I end up with a pretty good reinforced tie back. Here's another, this is the truss version, this is the ladder version. All right, so the ladder I can lay straight across into here. And you notice in each of these there is space between the two. Okay, let's talk about columns and pilasters. I sometimes call them pilasters. Forgive me, I'm from southern Missouri. Columns, you know what those are. They're vertical members. They're not walls. They're isolated vertical members. A pilaster is integrated with the wall. All right, so here's the column, and it's integrated within the wall. And you see these all the time in, basically the buildings we're all in. Government buildings, universities, schools, things like that. So you'll see these a lot with the masonry. Both can be reinforced, and you see this is essentially column reinforcement. It's just dropped in integral with the wall. Beams and lintels. This is like an edge beam for this wall, top beam tying everything together. This is a one that's over a window or a door, right? So we typically call those lintels, but it's the same type of idea. It's a little shorter than a typical beam. Okay. And so it's a special block unit where I fill it with concrete or grout, and it's got continuous reinforcement through here. Those all have to be reinforced. A lot of times it looks like I might have some kind of masonry lintel, that there's actually a steel lintel in this case. Okay, and so the masonry's just continues. The steel lintel takes up a little less space, but certainly I could have simply designed an actual lintel beam, a lintel in masonry across here as well. Another example of a steel lintel. This one is a precast unit where they said, here's the lintel, but in fact it's not a structural lintel, it's just aesthetic, and the steel lintel is holding it up. Gotta hate that. I said, you've got to hate that, by the way. So you have to hate that because I don't like it when we're doing things purely for aesthetics that look like they have some kind of function. So here is a case where I'm making a fake lintel. Why not just make a lintel? Stone lintel. So notice in this old stone wall, steel wasn't an option here. This is like Stonehenge. So you've got a single stone that crosses that area over the door. Here's an arch. It's another way of handling an opening. This type of thing. Think of this as your keystone, so the very top stone. And this one, it's a little different. It's not single stones, right? It's a bunch of brick fanning out. Here's a brick arch. You can see very effective way to do this. Here's another keystone. This steel lintel, in addition to this, depending on if this is actually a, so this could be part of the window frame or it could be designed as a lintel. It looks like it's more than likely designed as a lintel. Here we go, stone arches I'm calling it a lintel, but the stone arch to handle this opening. All right, so we'll stop with this and then I will start talking about the design codes.